Hey there everyone, Hitesh here and welcome to the course on data structure and algorithm. I know many of you have been waiting for this course for a really long time, but finally this course is here. And this course is designed in such a way that you don't feel that data structure is going to be tough. It's going to be super easy, very smooth to follow on, and you're going to just love it. Now, data structure and algorithm is a very crucial and important topic. And since you're already watching this video, I believe you have done already some of the research that it's one of the most important subject and topic that you should learn regardless of your programming knowledge, whether you work on Java or C++ or Python. This is an important concept and we're going to find it out why it is and what can it gives you the benefit of that. So let's start with the data structure and algorithm, and I usually call this as DSA because that's an acronym and I prefer to use that quite a lot. So get it into a habit. I call this entire stuff as DSA quite a lot. And let's get started about the data structure and algorithm. Let's begin this course. Now before we move on into the course, I would like to mention this one thing. An empty paper is always easy to write on, so be one. What does that mean? Now, I'm pretty sure that you're coming up into the data structure course after exploring a couple of other resources as well. That's a good thing. But the people who are just fairly new and don't know much about these concepts are much more easier to teach this DSA topic. Because the simple reason is you are learning from other books, other courses as well, and their way of teaching is a little bit different than mine. So I would highly recommend, if you're watching this course, an entire series, just try to just focus on this series at least for now. Once you're done with this series, I will personally recommend you some of the books as well as other resources that you can follow on. The reason for that is the way of explaining the other instructor is vastly different from what my technique of explaining is. And when you mix that techniques, you sometimes feel that one is wrong, one is right, but sadly, both are true and both are correct. So my recommendation is just completely empty out your mind, focus on what I'm saying, focus on the concept and understand these things. And then once you're finished with the course, you're free to explore other resources. So let's get started. Now, first and foremost, we all know that data structure is just a way of writing the code, of performing the different type of things that we want to do. One of the advantage that most of the people are not aware of it is it can also impact your pricing issues as well. Most of the people are aware of the data structure, that once you understand the data structure, you can optimize your code. That means your code is going to run faster and you're going to save some resources like memory or disk space as well. But what a lot of people don't understand is that nowadays we host our application on servers like Amazon, on Heroku, on DigitalOcean, on Netlify. There are so many resources. And if your code is not optimized with these data structure parameters, it's going to cost you more as compared to the highly optimized written code. So it's also important in terms of pricing as well. So that makes it very interesting. Of course, other things you already know, that in terms of competitive programming, in terms of better writing and nailing down the big interviews, this is one of the most important topics. So let's get started with the data structure and understand our first very essential problem. So let's just say this bearded guy is you and you want to reach to a friend's home. Now there are two paths in front of you, path K and path M. And I have deliberately written them as path K and M and not A and B. And there are two ways. One is the orange way to reach your friend's home and another one is green way. And before even I ask the question, you are willing to give the answer that, hey, choose the path K because it's more straight path and you're going to reach there faster. That means it's more optimized. So this is going to be better. But here's my point. It is not like you can just look at the code and can say this is more optimized or more like that. There are a lot of variables and a lot of parameters that you need to understand here. Let's just say I add more parameters. In the path K, there is some construction going on and there are a lot of potholes in that path as well, a lot of traffic jam as well. So it's going to take 2 hours to reach from the path K. The path M is definitely more zigzaggy, but it is very smooth road. We are going to have broader roads here, probably 6-lane highway. And this path can take you to just reach here in probably, let's just say 45 minutes. And this above one is going to take, let's just say 2 hours. You are obviously going to choose now the green one. So just like what you were thinking a minute ago immediately got changed because I introduced some more parameters in judging which path is going to be best. That's what my exact point is. The data structure is not about always looking at the code and finding out this one is better. No, we need to find out what are the parameters through which we are judging a code and how we can find out this is optimized and this is not optimized. So these are all things that matter. One more interesting thing I would like to point here is the reason why I have named it as path K and path M is because there are a lot of time in the data structure that you're going to see that this is an algorithm or this is the way of writing the code, and somebody is calling it as K, somebody is calling it as M. It doesn't really matter what you call that, as long as your way of styling writing that code is exactly same. It doesn't matter if you call it A or K. It should be same, it should be optimized, and that's all what we care about. So two important things that we have learned up here. Now one more thing. Now let's move on and take this thing into the code level. So when I go up here, first and foremost, very important note, when we take things into the code level, DSA is independent of programming language. And this is a very important truth as well as fact that you always should keep in mind. There are a lot of books in the market that says DSA with Java, DSA with Python. They are all true because DSA, data structure, is a way of writing code, and you can write your code in Java, in Python, and all other favorite programming languages. And surely we're going to choose one for this particular course, but you should not really get bothered much about it. I'll explain that which one, or you probably should already be aware of which one we are going to choose for this particular course, but it doesn't really matter. It's very independent of that. So now that you understand that one, for a moment, I'm going to deviate from the actual programming language that we're going to use, and I want to show you a programming code here. It doesn't really matter if your programming language is Java or Python or any other, you'll be able to understand this code. This is a fairly simple code. This code actually comes from a Stack Overflow discussion, and this is the actual discussion. And I have actually copied this code and I have pasted up in our presentation so that we can focus them up here. So these codes are coming up from this one. So let's focus on this code. There are two codes here. And the first one is how to add n numbers, and the second one is also how to add n numbers. So how we can figure out which code is better and which is not so better? Given the fact from the previous example, you now know that just by looking at the code, we cannot say that this one is bigger, that means this is not optimized, and this one is smaller means this is optimized. We need to figure out why are you saying this? What are the parameters, how you're defining that? One is definitely a bigger, almost 7 lines of code. Another one is just 1 line of code. So which one should I use? Which one is more optimized and all of that? In order to find out all these parameters, we're going to come back and look onto more of this data structure. I hope this sounds all interesting to you and all fun to you. This is going to be all an amazing and fun series, very easy to follow. So that's it for this video, and I hope you're enjoying this series, and let's catch up in the next video. Hey there everyone, Hitesh here, back again with another video, and this video is going to be a little bit shorter. Now there are two things that I wanted to discuss, so I thought let's keep them separate in the separate videos. So here's the first part and the next one is the second one. So let's go ahead and talk about that. In the previous video, we saw that just by looking at the code is not a good way to determine how good is that code. But the question here is, what makes a code good? And the parameters are usually different. For example, if I'm just looking up for the teaching purpose, my parameter is the code should be more readable so that everybody and anybody can understand it. But when I actually run the code on something like Amazon servers and everything, I want my code to be more optimized. By the term optimized, I mean it should be faster and it should take less memory consumption and probably a little bit of the less disk space as well. So these are the criteria that we usually follow. Now, just onto a side note, there are a lot of researchers do their research in their master's degree about the performance of probably a code, probably a chip and all of that. And through that comes up the two criteria of deciding anything, which one is the better way. So here we have two approaches here. So the way how we calculate the performance of a code can be determined by two ways. One not so good, another one very good method. So let's talk about the very first method. The approach one here is, again, these are all pseudocodes, means they look like code, but they actually don't run and they don't belong to any programming language. Let's just say, and this is a very common method, if you are doing your masters, you might be getting very familiar with that one. First and foremost, we calculate the time before running any method or any particular code. And once the code actually runs that, we again calculate the time reference, what time right now is after the running the code. And this time is being subtracted from the about time, and we get something like that. And in case you have done any kind of parallel programming, this is a one very common approach. We do that in that case as well. And on the sideline, I would say, yes, sometimes this approach is also being used in the research paper also, but this approach has its own drawbacks. And let's talk about what can go wrong in this approach. Although, yeah, this is a way to find out the performance of the code, but there are some issues with that. First and foremost, this approach is highly based on machine. That means what kind of processor you are using, i3, i5, i7, or anything like that. In that case, you will see that when we calculate the time and the function being runs here, then simply, obviously, the faster machine is going to give the faster, and we'll say that this code is faster, but the slower machine will give us a slower. So we don't have a quantifiable thing that we can say, yeah, this is the standard that we can follow. And apart from that, another problem is based on the processing. So let's just say your computer was busy in rendering a video, and at that time you're doing one test, and on the other time your computer was doing nothing, and at that time you run this code. Again, the performance and the time difference is going to be vastly different. So yes, I'm not saying that this approach is totally bad. In some cases, we still use that in the master's and PhD degrees, but this is not a viable approach in our case in the data structure and algorithm. So on a whole, I can say that we are not going to be using this approach. So what is the next approach that we can use? And in order to understand that next approach, we have to actually understand a few basic concepts about this kind of a same code that we have here. So let's go ahead in the next video and talk about what are the assumptions that we have to remember and what we can do to figure it out, that how we can measure this code as, is this a good code or a bad code? So let's move ahead and let's catch up in the next video with approach 2.